In the previous session, we have studied about queues, the different types of queues, memory representation of a queue using arrays as well as linked list, and the algorithm for Enqueue and DQ. In today's session, we are going to study about the applications of queues. The first application is simulation. So simulation is a set of numbers where it is used to denote the state of the system using queue concept. And next application is round robin algorithm. It is used in round robin algorithm to solve some problems. And third application is printer service routines. So in printer service routines, it works based on priority queue. So based on the priority of the request made by the jobs, it is going to allocate that particular job to the particular printers. So it also works based on the queue. And next application is various applications, various software applications works upon queues. And fifth application is various features of operating system. So operating system mainly works based on the concept called queue. And next application is multi-programming systems. In multi-programming systems, we are going to perform more than one program. So based on the priority, it is going to execute the programs. At a time, we are going to execute more than one program. Next application is, it is used in different types of scheduling algorithms. So scheduling algorithms is nothing but scheduling the jobs based on the priority. So these are all the applications of queues. So now let's see how to write a program for Enqueue and DQ operation of queues. So before going to write a program for this, let's recall what is a queue. A queue is a collection of items where insertion and deletion of an item takes place at different ends. So when it comes to the operations of stack, first queue function is used to create an empty queue. Enqueue operation is used to add an item into the end of the queue, and DQ operation is to delete an item from the front end of the queue, and isEmpty function is used to check whether a stack is empty or not, and size operation is used to return the number of items in the queue. In this program, we are going to first create an empty queue, then we are adding an item into the queue, as well as we are removing an item from the queue. Write a C++ program to perform NQ and DQ. So for this, first I have to create a class called Q. So in the class, first to create a queue, I am going to use a function called queue function to create an empty queue. To add an item into the queue, I am going to use Enqueue function, and to delete an item from the queue, I am going to use this DQ function. So what is the first step? First step, we have to include the required header files in our program. The first header file is #include iomanip.h. So this header file is used to provide basic services to the C++ program. Like it uses objects like scene and cout to send data to and from the standard input and output devices. And next header file is #include conio.h, which contains basic functions required for our C++ program like clear screen and getch. And next header file is #include stdlib.h. This header file is used to allocate and deallocate the memory. And next header file is #include iomanip.h. This iomanip.h is used to manipulate the output on the display screen. And #define. Here I am defining a macro, that is max of size 3. So whenever the compiler come across this max variable, it replaces with the value 3. Now I am creating a class called Q. So in the private section, I am going to declare the required variables. Always P should be in a small letter. Private, data type is int, Q of max. And I am creating the variable for front as well as rear. In the public section, I am going to declare the required functions. So which are all the required functions? Q, NQ and DQ. Q, NQ function. So it will not return any value, hence the return type is void Q insert. So instead of NQ, I am going to write it as Q insert. Here it needs a parameter called item to insert an item into the queue. And next function is void Q delete. This is to perform the deletion of an item from the queue. After inserting and deleting an item, to display the queue contents, we require a function called display. Void display function. So I am going to close this class by terminating it with semicolon. Next, we have to create an empty queue. So for that, I am using the function called queue. It's a default constructor. So as it is a constructor, while defining this function outside the class, no need to write the return type. So here we can directly write the class name. What is the class name? Q, scope resolution operator, and what is the function name? The function name is Q. Here we are creating an empty Q. So the front will be -1 and rear will be -1. Next, I am going to insert an item into the queue. So we are defining this function outside the class. So for that we have to first mention the return type. What is the return type? The return type is void. What is the class name? The class name is Q, followed by scope resolution operator, then the function name. What is the function name? Q insert int item. So while inserting an item into the queue, first we have to check whether it is in underflow state or not, or we can also call it as full, whether the queue is full or not. So for that we have to check for the condition. If rear is equal to max -1, here we are checking for the overflow state. If the queue is already in overflow state, we cannot insert any item into the queue. So in this case, we have to display the message using cout statement. So this is the insertion operator. We have to print it as queue is overflow. We have to return from this queue. We have to exit from this queue. So if the queue is not in overflow state, then we have to check for whether the queue is empty or not. So how to check? If front is equal to null. If front is equal to null, or we can write it as -1. If front is equal to null or -1, then if the queue is empty, then the point of front as well as rear will be 0. Here we are checking for the empty of a queue. If it is not empty, we can add an item into the queue at the rear end of the queue. See, while adding an item into the queue, we are going to add from the rear end of the queue, right? So for that we have to increment the rear pointer. So if this condition is false, we have to increment the rear pointer. R is equal to R plus 1. So we are inserting an item to the rear end of the queue, that is queue of rear is equal to item. We are inserting an item into the rear end of the queue. So close this function. Next is to delete an item from the queue. So we are defining this function outside the class. So for that, first we have to mention the return type void, followed by class name, that is Q, scope resolution operator, and what is the function name? The function name is Q delete. So while deleting an item, first we have to check whether the queue is empty or not. if the queue is already in empty state, we cannot delete any item from the queue, right? So for that we have to check whether the queue is empty. If f, that is front point, is equal to -1 or null, we have to print it as queue is underflow. If it is already in a empty state, then we are exiting from this queue. So here I have used return type 0, which exits the program without any error message. So if the queue is not in empty state, then definitely I can delete an item from the front end of the queue. From the front end of the queue. That is item, we are deleting an item from the front end of the queue. We are deleting an item from the front end of the queue. So, after deleting an item, here we are checking for another condition, that is whether a queue contains only one item. If rear is equal to front, if rear is equal to front, that is if this queue contains only one element, means, so this is the same as front pointer as well as the rear pointer of that item. So if we delete that item from the queue, then the front and rear becomes 0. So if I delete this item from the queue, so the queue becomes empty now, right? So then the front and rear points to -1. F is equal to -1 and rear is equal to -1. So if the queue does not contain only one element, means we can increment the front pointer to delete the next item from the queue. That is f is equal to f plus 1. F plus 1. So here we are printing it as item deleted. Item deleted. So close this function. So here what we have done, we have created an empty queue and here we have inserted some items. Here I have deleted some items from the queue. So after performing all these operations, I have to display the contents of the queue. So for that I have to use the function called display function. So we are defining this function outside the class. For first we have to write the return type followed by class name, scope resolution operator, then the function name. So the scope resolution operator tells that this function is referring to the class queue. So while displaying the contents of the queue, first we have to check whether the queue is empty or not. So for that we have to check the condition. If front is equal to -1, then we have to print it as cout. Using cout statement, I am going to print it as queue is underflow. If it is empty, we cannot print any items of the queue, hence we are exiting from this condition. So if the queue is not empty, we can print the items of the queue. Else, if the queue is not empty, I am going to print the queue items. Cout Q contents are. Using for loop, we are going to print the items of the queue. For int I is equal to F, I less than is equal to R, I plus plus. Cout set W of 5. So it is used to set the field width between the items of the queue while displaying. Q of I. So this is about display function. So now we have to create the objects for the class called queue. So in the main function, I am going to create an object for the class queue. So how to create an object? First class name followed by the object name. What is the class name? The class name is queue. I am going to create an object called Q1. Q1 is the name of the object. Clear screen function to clear the contents of the previously generated output on the display screen. Now I am going to call all the functions using the object name. So that is Q1 dot Q insert. I am going to insert an item called 10. So again I am going to use the function Q insert to insert an item called 20. Next I am going to call Q1 dot display the queue items. That is Q1 dot display. Then I am going to delete an item from the queue. So I am going to call the function called QDelete using the object name followed by dot operator Q1 dot QDelete function. Then I am going to display the queue. GetCH function is used to hold the display screen until the user presses any key on the keyboard. So now let's see the output of this program. So here first it will call the insert function. So here we have inserted 2 items into the queue. So after inserting an item into the queue, we have called display function to display the contents of the queue. So here it will display it as queue contents are. Queue contents are. So here it will display 10 and 20. Next, here I have called QDelete function to delete an item from the queue. So as usual in a queue, it will delete an item from the front end of the queue. So it will delete 10 from the queue. Now it will display it as item deleted, that is 10 deleted. Deleted. Again we have called display function. So queue contents are. Queue contents are. Now it contains only an item called 20. So this is the program for NQ and DQ of a queue. Thank you.